Welcome everyone! Thank you so much for joining us on this rainy Tuesday.
Woo!
Yeah, let's get a woo. How many people know what an LPU is? Wow. That was one of your questions. Sorry, but the rest of you still came out. Maybe you'll learn. That's great. And we're excited here to have Alec McLean to talk with us about LPUs and whether the new GPUs. He is from Groq, and I'll let him do his introduction in just a second. But first, we're going to have our exciting announcements. Data Community DC is the umbrella organization over Data Science DC. This is a Data Science DC meetup. Hope you're in the right place. And we have a bunch of different meetup groups under us. Encourage you to check them all out. You can see some of their logos there. And you can go check them all out at dc2.org. Go there if you want to see the groups and see what's happening. We got all kinds of goodies for you. We would like to thank our sponsor, Rotational Labs, for giving us money so that we can do these kind of events. Meetup isn't free, and we really appreciate that. So just treat it right there. Schedule 30-minute call, request data product requirements doc template, all the goodies. You want to say anything, Kruma?
Sure. So just a little bit about Rotational Labs. We are a boutique AI consulting company. So if you or your organization is kind of trying to get started or level up in AI, feel free to reach out. We also have an AI playbook we walk you through use cases where you can use AI in your organization. But yeah, again, if you want to learn more, we're also happy to do brainstorming sessions with you as well. So if you're interested, my email address is right there. streamlive.io.
Are you hiring?
No? Okay. We will have more on that topic in a second. We also want to say thank you to Excella. We are all in Excella's space using Excella's Wi-Fi, eating food provided by Excella, and lights. I mean, there's a lot of things really happening in this room. So thank you, Excella. Will, you want to say anything about Excella?
Oh yeah, so Excella is a technology consultancy. We help our clients solve business problems with technology. We do modern software development as well as AI analytics. So I do lots of cool data engineering data stuff here. We are hiring, so if you are a cloud engineer, DevOps engineer, Python engineer, we also often hire a lot of like data viz, data analyst people. I think we're currently good on data science roles, but that changes pretty frequently, so we'll have. But you can check out the website or talk to me afterwards.
Sweet, Excella.com.
/careers, Excella.com.
Awesome, thank you. All right, thank you, sponsors. So, if you need to get in touch with the organizers of Data Science DC, that is Janet, who is not here tonight, and myself, and Abigail. Awesome. So, talk to any of us, and you can reach us on LinkedIn at the places located here, or just come chat. We do have a diversity statement, and you can check that out. I won't read it to you. We also have a code of conduct. You can check that out too. We just want to treat everyone well. If you have any issues, come talk to myself or Abigail. Or talk to Will. Will's also the head of Data Community DC, so he's got a role in all of this. We do encourage you to connect with us on YouTube and on Slack. We try to keep the conversation going there, so check that out. I wish you had a QR code. What century are we in, really? Note to self, do that before the next meeting. But check it out. Upcoming events. Well, I didn't finish this slide apparently. We did something on April 22nd. It was really great. I hope you were there. We don't have anything on the calendar right now for Data Science DC, but we always are adding new things. If you're on that meetup list, you will get regular announcements. But really, the whole point of having this was to get to the next slide, which is about your announcements for events. So, Mary, go ahead.
Howdy. Hi. Hello. I am former co-director of Women Who Code DC, which is no longer, but now we have a new organization called Women and Gender Expansive Coders DC, which is the new organization that we are launching. We have 2 events coming up. We have one this Sunday at 11 a.m. and it's craft and structured coding interviews. So you do coding interview questions and you take craft breaks in between to really, solidify that knowledge. That'll be this Sunday. We do have a meetup page. If anyone's interested, just come find me. And then we have another one that will be right here at Excella on June 6th and that is Origin Stories, the journey to CEO and founder in partnership with DC Startup Women, which is going to be an awesome panel of founders and hearing their stories. So if you're interested in any of these, come talk to me. I can show you where the new meetup page is, and yeah, that's it.
Yeah, cool. Awesome. Other meetups, people, yeah.
You ready one?
Yeah,
Yeah,
of
okay.
course.
Hi everybody, my name is Nicole Janeway Bills, and I do data management, so maybe less relevant for the technical people, but if you're interested in like learning more about data governance and writing data quality scorecards and like getting the data to flow through the business and actually add value, then my team and I do meetups that are all virtual. So we have one tomorrow at 1 p.m. and we're going to be talking about data storage best practices. We also like help people get ready for a professional certification in data management. So if you go on LinkedIn and you look at like data strategy professionals, we have a group, and that's where we post information about meetups. We do it 3 times a month, and like everything that we do is virtual. Trying to hit like different times of day to make it relevant for everybody. So again, it's like just data strategy professionals, and we're on LinkedIn and other socials. So come talk to me if you're a data management person.
Awesome.
Thank you.
Thank you. Other announcements? Yes, go for it, sorry.
Hi guys, my name is Sunny. Feels like I'm doing this every time, but I'm a recent graduate with a master's degree in physics, and right now I'm going to break into data science industry space and looking for entry-level positions. So I love data science, and throughout my academic journey, I've done research in physics using machine learning to solve a wide variety of mathematical and physics problems. I love it and would like to keep doing it. So if you know of any people hiring entry-level data scientists or like data engineers or Python engineers, please let me know. Thank you.
All right. Other folks looking for jobs, hiring, meetups, just fun things they want to talk about. Anything, announcements?
Oh, it's not me, it's on LinkedIn.
On May 30th, we're going to be having the full stack data science meetup here at Excella, so that's going to be super fun. We should have a presentation on AI orchestration with the Mage framework. Plus, I believe that will be coded with generative AI DC. So there's going to be some fun Gen AI stuff there as well.
Cool.
Also on May 30th, the Bethesda Data Science Meetup group is meeting up in Bethesda, and I believe Abigail is presenting there.
No, it's somebody else. It was the guy who did the.
And are you not presenting there?
I couldn't double book.
Yeah. Anyways, there'll be an event here. It's going to be awesome. There's also going to be an event up in Bethesda, which will also be awesome.
Wow. Will is a nice guy, I'm just going to say.
That's me for
We already knew that. Yeah, definitely. Supporting the community. All right, any final announcements? Okay, sold. So just thank you for attending tonight. We are excited to hear Alex talk. After the talk, some of us have to go to Frisbee practice. Others of us might go across the street and grab a drink at the name of the bar that I always forget. So we're not going to House something. You can't miss it. Just like walk out the doors. We'll be there. And there'll be other people going there. So awesome. With that, Alec, take it away.
Thank you. Thank you, Janet, Jeff, and Abigail. Really excited to talk to you guys about LPUs today. Rami, would you mind standing up for a second? So Rami has some bags from Groq that anyone can take.
Ooh.
These, yeah, orange bags that say Groq and stickers. So please take everything. I don't want to bring anything back home. But yeah, they're at his table, so feel free to grab one on the way out. And I love how everyone has been talking about GPUs. I know traditionally data scientists don't really talk about hardware level aspects. They like to think about statistics, or really just pip install scikit-learn, import scikit-learn, and build a model. But I think hardware is important, especially when we start thinking about things like generative AI and large language models. in 2022, everyone, got to experience what it was like to play around with ChatGPT. Previously, we could do some cool things like name entity recognition or detect if this is a cat or a dog, but we really haven't had that frictionless experience like we did with ChatGPT. And that was really, really cool. But one of the downsides is it's not exactly like having a human conversation with something or someone. Sometimes they lag, they like chunk information out to you, and it's not really having a conversation. If I were to speak like this, like no one would pay attention to me. And I think we want to move the industry from a monologue to a dialogue with these machine learning models. These are going to be tools that we can use in the future to help improve, optimize our workflow and daily life. So that's what I'm here to talk to you about today, having more natural conversations with AI. Here's a brief agenda, intro, motivation, problem, solution, and then some demos. In terms of just an introduction, I'm a machine learning architect at Groq. That just means I support salespeople and engineers if they have sales-related questions or technical-related questions around Groq and machine learning or how to architect one. Previously, I was at AWS and who's that one? So Groq, I know a few of you raised your hands and said you knew what the LPU stood for. And so I know a lot of you don't. So the LPU stands for Language Processing Unit. So Groq is a Gen AI solutions company and the creator of the LPU Inference Engine. And we deliver the fastest inference on the market today. The fastest, using the least amount of power, and the cheapest. But taking a step back, and we already talked about this, but everyone and their grandmother has heard about large language models. Everyone at work, I imagine a lot of you are data scientists or engineers in your work, and your boss is probably saying, hey, build me a ChatGPT. Can we do this, can we do that? And you're like, oh, all right, it's gonna cost us a lot, or we might have to pay someone else to do it, or we're gonna have to expose our data to a third-party API. So everyone wants to use them. However, like I mentioned earlier, some of these applications are a little slow. And so if we need real-time interaction with these models, we're gonna have to do something a little different. And this obviously depends on the use case and what you're doing, but in inference settings where latency matters, i.e. you need a fast response such as a call center, this dial-up paradigm won't really work. And so just a couple of the pain points that we see with large language models at scale right now. The first is just really around deploying models. So a lot of organizations, people, enterprises spent a number of years and months building machine learning models, and now they need to operationalize them and put them into production or inference, right? And the standard architecture is a GPU, or graphics processor. The thing about those is they're not optimized for machine learning, deep learning, or really inference. They were developed 20 years ago for processing video games. So when you would play Mario and the screen would just move to the right, folks were like, hey, let's do something better. Let's make this world more 3D. That's the original intention. And so the first pain point is they're just not optimized for real-time inference. The second is around data privacy and IP protection. I know a lot of you have probably played around with third-party APIs like OpenAI or Anthropic, and they're wonderful. Don't get me wrong, they're great. However, if you need to, if you have sensitive data and you cannot expose it to third-party apps, you're running the risk if you use those. You could leak PII, or if you work in the federal space, you could leak potentially national security information. And so, and you can also make the argument closed source models in general are less transparent. And when you think about equitable AI or responsible AI, you can't really dig into anything from a closed source model. You can't pull down the weights from Hugging Face. You don't know what's happening between these layers. You have literally no idea what's happening behind the scenes, so you can't explain anything to your stakeholders. The third pain point is around human capital. So with a GPU architecture, you have things like a kernel. If any of you in the audience know CUDA. So you have kernels, you have other things as well, but then you need to port those over to a GPU. And you have folks like kernel developers who are really specialized and know how to optimize that code to run on that hardware. The problem is not every organization has a mountain of kernel developers, kernel engineers to do this. So the first pain point here is not every organization has the same access to the resources. The second aspect of this is it's potentially a really manual process. If you have a very custom kernel or function within your code, you need to literally hand crack that and then port that over. So there's a bottleneck because just there are not enough people, but there's also a bottleneck in terms of innovation too, because it literally slows down the pace in which you can deliver. And then the fourth thing that I don't know if people think about as much, but I've had a number of conversations with people in the audience tonight around how many more people are talking about GPUs within the last couple of years. And GPUs are great. However, one of the issues with their leading providers right now is the majority of their components are built offshore. And so from a supply chain perspective, that's risky. If you need a GPU in a month, you're probably not going to get one. You have to compete with hyperscalers and who have access to these. Then you also need to present a really strong business case why you need access to those GPUs. So if you need something tomorrow, it might not come. And so with all of these things in mind, leaders, engineers have to make really challenging trade-offs between performance, cost, and accuracy. And then one other thing that I didn't mention is just in terms of scaling. And this really comes down to the fact of why GPUs were developed in the first place and how over the last couple of years they've been used for deep learning models and to train deep learning models and for inference as well. So on the x-axis, you have literally the number of processors. On the y-axis, you have the p-flops. And so what the main takeaway for this graph is after 32 graphics processors, that p-flops drop dramatically. So even if you add more GPUs to your workload, you might not necessarily see the same proportional decrease or increase in p-flops or decrease in latency at that point. And that's just because of the way they've been architected. And so let me take a step back and then talk to you about the LPU Inference Engine. And I think the best way to do that is to mix up the agenda quickly and show you what a demo looks like right now. So all of you can go to this website, Groq.com. You'll be presented with this chat interface like you've seen with a number of other different providers. You can access some of the open source large language models that we have available, Gemma, Llama 3, Mixtral, and you can begin playing with it. So you can ask a question like, what is generative AI? And of course, during a live demo, what happens. So yeah, I heard a couple woos in there. So over the last couple months, in order to handle all the requests, we've had to queue requests as they come in. And so it's not necessarily that this is working slow, it's just literally someone else came in line, I was next up. So that's what you're seeing. But I want you to think of this number here. So 875 tokens per second. So I know a lot of you are data scientists, but for those of you who are not, a token is essentially a word. It's a unit of measure that computers use to quantify information for large language models. So a token is a word. It's like generative, it's artificial, it's creating. And so what this metric is telling you is that this model, Llama 3 8 billion, running on the LPU Inference Engine, is generating 875 tokens per second. That's really, 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 really fast. We can even change that to Llama 3 70 billion, which is much bigger, and we can ask a question like, what are transformers in machine learning? And you can see, it was super fast, and it's significantly larger model. And so because this is running on our hardware, we're able to speed up the performance tremendously. Did you have a question?
Just a quick question. Is that referring to the output, or it's just the total processing? Just what I've seen
Yeah.
with other ones is that the more input you give, the slower it is.
Yeah, great question. So this number 302 refers to the output speed. You can dig into the details a little more on here. Where is it?
How does the lightning bolt and it, yeah.
Yep. Oh, you played with it.
No, I just
Okay. Yeah. So if you just go over the cursor and this number, you can see more of the finer grained information in terms of input, output, and total time as well. So that's one option that all of you can do right now. You can pull up your phone and do it. We're going to ask you just to sign in, but we don't track any information. Any prompts, anything you do to the system prompt, any of the parameters, we don't track. We only save metadata. So time of the query, how long the query took to execute, time of the first token, things like that. Anything related to your actual prompt, we don't store. And that just leads us, to why we really see the value in open source models. Just like open source technology a number of years ago, we believe in open source information. And so as these models continue to get better, we believe pushing out open source models is the way of the future. So you can interact with this, or if you go down to the bottom here and click on Groq Cloud, it's going to verify that you're a human, but you will get to a playground like other websites you've been to. And like here, you can ask it to a question, explain the importance of fast large language models. You can adjust the sys prompt. You can play around with some of the parameters, temperature, max tokens, etc. And you can even change some of the models as well. The best thing about this, though, is you can go to API keys section and generate a free API key today and start developing. And it's all free. So do it today. It's not going to last forever. Yep.
Are there any sort of limits on things?
Yeah, so there are rate limits. Because it's free, we have to set some rate limits.
Oh, it's free?
Yeah. yeah, it's free. It's free, but there are rate limits associated with that too. And so you can build demos, you can do tests. It's not something you can put into production.
So you're running LPUs.
Sorry?
You're running on LPUs.
Yep. So we've compiled these models, we've exposed the endpoints, and they're running in our data center as well. And a number of folks have done demos like this in different parts of the world. Our data center is on the West Coast, and regardless of what time zone they're in or what geography, you don't really see any latency. It just works as well. Yep.
Can I bring my own model?
That's a good question. So right now, we need to build out the infrastructure and hardware to support not just the current models that we have, but also the demand as well. So that's on our roadmap. We will allow you to bring our own models or bring a fine-tuned model, but we for the foreseeable future won't fine-tune or train. We're just going to focus on inference at this point. Yeah.
Calling it an inference engine, so.
Exactly. I mean, you'd be surprised the number of questions we get. Can you do training? Well, yeah, I guess, yeah, but. Yep.
So what does inference mean in the context of large language models?
What does inference mean in the context of large language model? It means something like this. Explain the importance of fast large language models and the response you get. So everything here. So it's literally just like a prediction.
just to follow up with his question about bringing your own model, were you referring that you guys don't train, or just if someone already has a model just set, ready to use, it's not quite available yet?
Yeah, so let me be more specific. We don't train, we won't train for the foreseeable future. But in the near future, you will be allowed to train on a GPU or some other hardware and bring your own model to run on our hardware. Yep,
Are you gonna cover like the code base and everything?
a little bit,
Okay.
a little bit.
Because I might take my questions until then.
Yeah, so, yeah, we can do that. Yep,
So then the current offering is only limited to the models that you guys provide?
yes, exactly. And we are releasing Whisper this week. Yep.
A related question, so what sorts of models can the hardware handle? Like, it's called an LPU, so language, but like
Yeah.
just, it's not general purpose like a GPU, right? like,
So,
what can it
yeah,
do?
so we're an 8-year overnight success. We were founded in 2016.
Yeah.
And in 2016, the world looked a little differently. And so we have a number of different proof points around computer vision or different types of models as well. But since 2022, 2023, the strategic direction of the company has been more towards large language models, because that's what a lot of our customer base is asking for, and even more Gen AI specific, so multimodal, speech synthesis, things like that. So we can work on other types of problems, other architectures too. It's just right now, the direction is more large language model focused.
Okay.
Sorry, when you say that, do you mean transformer specifically, that's the architecture, or?
So I mean, no, not transformer specifically. Can work on other backbones too, but we're a small company, we're a startup, so we have to meet customers where they are too. And I mean, at the end of the day, the models I have up on the screen here, that's what we've heard are more in demand, and they just happen to be more transformer-based models. So, yep.
So my clients are federal. Could I buy an LPU from you, take it into the CIA and deploy it there?
Yeah, so, yeah, you could. So, we're getting a little ahead, but I like the enthusiasm. So, go-to-market strategy, we offer literally racks that you can put in a data center that you manage or that we manage. Or we're building out this API side of the business too. So if you don't want to buy hardware, you just want an API call, stick it in your Lambda function on AWS, you can just get that immediately. And we are going through the proper approval channels for the API side to get FedRAMP certified, and then on the on-prem ATO side too. Yep.
So you guys also manufacture the chips and stuff?
Yeah. Well, so I mean, I'll back a little bit. we like the last point I had on here, just in terms of the infrastructure availability and cost, we recognized that was a problem that a lot of customers had to deal with. And so we made a conscious decision to design, engineer, and manufacture 100% of our chips within North America. And so we're not building them, we work with companies to do it as well. We work with global foundries right now in upstate New York. We're moving to Samsung in Texas. But all of it is 100% designed, engineered, and manufactured within North America.
I'm curious what dice.
14 nanometer. Yeah, exactly. And so,
Is there a reason why 14 nanometer?
I mean, that's what we were able to work out with global foundries.
What's the question about 14 nanometers? What is that?
So literally like the size of the chip. I have an image. I have. It's a great segue into the next slide. So this is like what a graphics processor looks like, and the state of the art. I mean, there's better ones that are gonna be on the market now, but what you see here, 14 nanometer, that's literally the size of like the die on the chip. So like the computer chip is very, very small. And so you have these GPUs that were designed, for processing graphics, They were not originally designed for building models, training, or even inference. And so the first problem is programming is hard. Let me just get this thought out, guys. First, programming is hard. You need to know CUDA, you need to know kernels, threads, work blocks, you need to effectively manage that parallelism. The second component of it is there's multiple cores on a GPU. And that's great because the core can work on a small task, a small workload of a larger task, right? That's how you parallelize work and work more efficiently. The problem is if the data the core is working on is not in its cache or not immediately accessible, it has to go out and fetch that from another component. That introduces lag and a wait time. On top of that, all of these cores might be in a similar situation. The data might not be in its cache, and so you have to wait for the data to get from your cache, but then you also need to compete with other cores in that GPU for access to that information. So ultimately, that just leads to unpredictable workloads. Meaning, if you need something to respond in X amount of time, because of the nature of a GPU, you might not get that, unfortunately, all the time. I'll stop now. I think you were first.
Sorry. So this was something I was wondering when you said that. So you were kind of hinting that you're not dependent on TSMC.
Yeah.
But I do know that they are at a much smaller process node, and I'm curious if this chip will scale down to that node as other like foundry providers can do it.
Exactly. Yeah. So our V2 chip is going to be 4 nanometers. Yeah. Mm-hmm. And that's going to be released 2025. Yeah, and so with each version, the form factor for everything will shrink too. So the chip, but then also the associated rack too. Right now we're at a 42U rack, but we're just trying to compress that form factor until we're ultimately like the size of a shoebox. I think.
Question. So my understanding of all this AI stuff is that it's basically matrix multiplications for the weights plus the bias. So I think you're saying that at a high level, you're doing the matrix multiplications faster, only for inference, because we're not talking about back propagation or anything. Is it true that so question is, are you doing any of the, like the transformer implementation in hardware? Or is it just okay.
So one of the core design features is to have memory on the chip itself. We don't use HBM at all, and the notion of memory in our chip is more flat. It's accessible by through every chip in the network, and so we don't rely on one component there. And so the chip has access to everything, and that way we're able to essentially shard the model across all of these chips, the weights, activations, etc. Additionally, we have a very unique networking topology where all of these chips are stacked and they're interconnected from one another. And I didn't get into this, but instead of building the hardware first, we focused on building the software and the compiler, and then build an associated hardware to complement that. So all of this is software scheduled. So at compile time, we know the most efficient data path from point A to M. What that also means is we're able to profile the power usage on the chip too. So if you're comfortable with, I don't know, a 5% decrease in performance, that might yield a 20% reduction in power as well. And don't quote me on those numbers, it's just more of a hypothetical scenario. So you can control really nuanced things like that. And so we're able to store the entire model on the network. And because the network is literally interconnected, it's a flat memory hierarchy. We don't have any HBM NICs routers. It can just scale linearly. So what I was talking about earlier, even if you add more GPUs, that might not necessarily yield a decrease in latency as you would expect. If you add more LPUs, that will literally decrease your latency by a proportional factor. Oh gosh, sorry, I think you were first.
Yeah, so would it be accurate to call LPU like a kind of embedded system made for LLM alone?
What was the last part?
Like, is it just accurate to call LPU a kind of embedded system, like kind of what you have for like self-driving cars, but for computer vision?
I would just call it more of an inference platform where we supply the hardware and the software. We're vertically integrated. I think you were next.
So
Sorry.
since you are like showing this slide and mentioning those like the chicken profile, for example, power, so do you have some notion of like system clock or something? Like how many whatever megahertz or whatever the count you have? Like if you can.
Yeah, so I can't get into too much detail,
Okay.
but we also have papers dedicated to this as well. And so we do have an internal clock, and all of that is scheduled. And so they, when you think of these vertical slices, yes, one of these vertical slices is devoted to matrix multiplication. Another is to literally switch information or reshape it. And so we have this clock where at every clock cycle, the compiler and software says, you're gonna do this, you're gonna do this, you're gonna do that. And that's how it's able to keep track of it.
So how many chips are necessary to run like Llama's 370B?
370B is, it's 640.
640 chips.
Yeah.
And how much does each chip cost?
Not at liberty to say that. But what I will say is, if you need a very large system to run a very performant large language model or generative AI application, it's very competitive with the market. And if you need something that uses lower power, a more immediate supply, we can work with you to negotiate what that price might look like. Thank you. Yep.
If you could go back to the previous slide.
This one?
No,
This one?
yeah. So there mentions non-deterministic execution versus deterministic predictable execution. What does that mean?
So when earlier I mentioned with the GPU, you have multiple cores, and with let's just take an example of a transformer. With the transformer on the GPU, you have the HBM storing a lot of the weights, the KV cache. And so what happens in application, you have computation happening on the chip, but the majority of, I guess, what happens is literally pushing information to HBM, pulling information from HBM, and then running computation. And because you're constantly pushing and pulling, the cores don't know when they're going to get the data. And because if you don't know when you're going to get the data, you can't say, hey, I'm going to be finished at this exact time. And so that's what we mean by non-deterministic. With the LPU, because everything is software scheduled at compile time, I know the job I'm going to do, and then I know what I'm going to deliver. I'm going to deliver it to you. You know exactly what you're receiving. You know your job, and then you can pass it on to the next person. So the way I like to think about it is, and maybe one analogy you can think of is an assembly. So when we first started building cars, each team of 10 people or so would have a little area like this. They would build the car. They would go out, get a tool from the toolbox, go back. They would go get another tool and come back. And they would repeat that process until the car was built. And then Henry Ford came around and was like, hey, that's not an efficient way to do it. Let's build an assembly line. And so I'm gonna stand here, I'm gonna do my job, I'm only gonna do my job. I'm gonna become an expert at my job because I'm doing it literally 24/7. So I'm gonna pass it to the next person who's gonna do their job. They're an expert in that job. And so we're almost building an assembly line approach. And so with this graphic here, you see multiple cores, you see multiple HBMs, these switches, and you see tokens on the left-hand side. And you see this interaction between core, HBM, data being routed via a switch. And that all leads to almost like drip like coffee. It can be slow sometimes. Compare that to the GPU, where you can literally stack these chips together. They have shared memory, so the KV cache, you just literally, you can pull it very easily and then produce that token. And so we're building that assembly line approach. Yep.
So, wouldn't that be a compiler issue versus a hardware issue?
Oh yeah, exactly. But the compiler, we built the compiler and the software first, and then the hardware complements. So
NVIDIA could make a better compiler.
Oh, well, I see what your question is. Yes, but they still have to deal with things like HBM and switches and routers. And so if you add more GPUs, the GPUs still have to talk to each other over a switch. And they still have to pull and push information to an HBM.
But they have optimized hardware architectures as well. Like they're interested in having like the highest memory bandwidth as well. That's in their interest.
Yeah, sure, but I mean, when you think of what you see today, they're like the output rate for tokens per second is not as high. So what does that mean? They're not optimized for that as well. I think you in the back, yeah, sorry.
Yeah. So from what I'm gathering is your LPU basically getting away from the limitations of branch prediction and trying to make your software deterministic in what what data is pulling into the cache on the processor at a very consistent rate. And if so, would you be looking into offering an LPU at certain industries? Like I know NASA and certain embedded devices would benefit from a deterministic processor like this.
Yeah, that's something that we're really committed to working with the federal government. I'm on the public sector team, and that's a lot of my work, working with organizations like NASA or any other agency as well. So yes, the short answer is yes, but at the same time we have to first, a lot of our conversations are helping people understand what is possible today and also understanding what the demand is. And we really excel at large problems. If it's something more like an edge deployment, we're not really able to do that right now.
Just a quick follow-up to
Yep.
that. Shouldn't you also focus on the security benefits of getting away from branch prediction? Because it's like every other month there's a research paper about the security vulnerabilities with branch prediction-based processors. I feel like that would also be a selling point towards your LPUs compared to, say, NVIDIA GPUs.
That's a really good point. Yeah. And yeah, I think that, yeah, we haven't yet, but I appreciate the feedback. Yeah, you in the white jacket.
Yeah, can you please help me understand in the diagram what does the color bars mean, like the blue?
Oh, nothing.
They look pretty.
Nothing, yeah. It's more for just style. Yeah, they don't mean anything. It's more of just being, I guess, one way.
I think that's allocated to each stack.
It's more, okay, I see what you're saying now.
Different types of tasks.
It's a token.
Oh.
It's a token. And so, so, I wish I could stop this. You see it's like an input sequence of tokens, and those tokens are being activated at different times on these graphics. So you see on the left-hand side, they're trying to parallelize them and feed them in across these different cores. On the right-hand side, you see it's just being fed in almost an assembly line approach. Let me get.
Yeah. So what is your hardware optimized on? Is it like optimized for like calculating the attention layer of the transformer models or something like that? And I guess my another question is, so the GPU use CUDA as a component framework, and you mentioned there's a software for LPU. What would that mean? So why is it easy?
Yeah, so it's the first part of your question goes back to the attention, and that really leads to just like the on-chip memory that we have and the ability to share that memory with other chips in the network too. And what was your second question? Oh, around CUDA. So the high-level workflow of what you would do is you take your PyTorch TensorFlow model, convert that to Onyx, and then from Onyx we can compile that with like something like Python, something pretty standard.
So you have software that is supported by PyTorch as well?
I believe that is on the roadmap, but right now the workflow is first take your PyTorch model, convert that to Onyx.
But you already have this C library. The program is up.
I guess is there a CUDA equivalent to LPU basically, is what he's asking.
No, there's no, yeah. Sorry if I misunderstood your question, yeah. I think,
Yeah, I think I can have a thought and just correct me. So, I think your advantage is, I think you mentioned it, is that you're much better at this whole serial processing, and the LLMs are naturally in inference mode. They are a serial process versus like the training process is much more parallelizable, even if they're still LLMs. Is that what explains the advantage from your chipset? Because you like the results that come out depend on the previous results that you generated, right? So
Yeah.
There's no inherent like parallelization there that you think you meant to.
So I think to answer your question, it's helpful to understand the context of where Groq was founded. So our founder used to work at Google, and he was actually one of the inventors of the TPU. And that came about because he was interacting with folks on one of their ML teams. They were developing like a translation model or something. And one of the great things about researchers is that they can create really robust models. But they don't always think about scalability. And so for him, it was, hey, I really love machine learning. How can I democratize it, so to speak? And with that, it's really only on inference. And so from day one, it was really, how did we solve the inference problem? GPUs are great, but we think they're better suited for training. It's an and discussion, it's not really an or discussion between NVIDIA, AMD, Intel, and Groq. There's a whole, we can all work together. And when you think of that new ML ops pipeline or LLM ops pipeline, there is a retraining or fine-tuning piece that happens, not necessarily on Groq today, but there is some piece of that. So from day one, it was really all about inference. We can train, it's just that the market is more saturated right now. Yep.
I have a good question. So, correct me if I'm wrong, but I think inference task is very easy to parallelize. So basically, because you have predict just one unit, and if this is the case, basically you can just run a bunch of CPUs instead of having one GPU. And so that's kind of the question is, what's the advantage of this system versus like large number of CPUs doing the same thing? And the second is, so there's also this tons of processing units.
Yep.
So I wonder if you can comment on kind of them relative to the system.
Yeah, so I mean, yeah, CPUs, they can certainly do that, but when we think of very large models like Llama 70 billion, it's not really cost effective to purchase millions of CPUs potentially, right? And so then you start thinking about, okay, what's a more cost effective way to do it? Okay, GPUs. Okay, well, maybe you could do that, but there might be a shortage, you might not get it, but they're not optimized for inference. And so that ultimately led us to say, okay, hey, why don't we redefine the problem? Let's not even think about what a current GPU or TPU looks like. Let's have a blank canvas. And so, yeah, for TPU, tensor processing unit, our founder was one of the folks who created it. But I mean, that's for training and inference too, and it's more or less very similar to a GPU in some ways. This is just different, focused only on inference. Yep.
You made a couple of comments about power being cheaper and using lesser power. What's your comparison?
So with a GPU, a lot of the functionality involves reading, writing data to an HBM. And so for a read-write operation, that's between 4 to 6 picojoules, and then data transfers are around 20 picojoules. With an LPU, the read-write operation is 0.6 picojoules compared to, and transfers under 10, maybe 8 picojoules. So there are dramatic power savings there as well. I think you had your hand raised and then lowered it. Okay, maybe
I might be well, I'm just waiting. Okay. So I had a burning question. So
Okay, yeah.
I'm a big fan of TinyGrad. I don't know if you've probably heard of it. So one of the
George.
by George
Haas,
Haas.
yeah.
Yeah. I'm actually on their Discord.
Oh, right on.
And one of the theories is that if you reduce the number of kernels that's required to run a model, then you can make developing it for custom hardware considerably cheaper. And I think they got it down to something like 25 kernels. But the problem is that if you reduce the number of kernels, then you also have to retrain the models and stuff. And so I was wondering, is that like on the roadmap to like kind of do all of your own custom kernels that are highly simplified, or are you still going to be like backwards compatible to like NVIDIA?
So we are kernelless.
Oh wow.
Yeah, we don't have any kernels. We have maybe a handful of operations, and yeah, that's not going to change. And then every iteration of the chip will be backwards compatible. Or sorry, yeah, the software for each iteration of the chip will be backwards compatible with the chip. So if you have a V1 software chip and you migrate to 2, the software will work on 2 as well. And vice versa. Yeah.
What would you like to talk about?
How much time do we have? Is that what you're
So no. Well, I do have to get a frisbee practice a little bit, but it depends when how much. We have room for a little while. We can go for another 15 minutes or so, maybe.
Okay, so yeah, I think one of the slides I just want to maybe leave you guys with is this notion. On the left-hand side, I imagine a lot of you have driven around the DMV or another major city in rush hour, and it's really unpleasant. From just
Can't watch this.
waiting time perspective, you'll be in this gridlock traffic. Who knows the reason why you're going to have to make these weird turns? But from a car perspective too, the gas mileage is really poor, right? And so let's contrast that with this idea of a smart city for AI, and the idea being, hey, if we could tell you when you needed to leave your house to get to work in the quickest time using the least amount of gas, and that was going to give you the least amount of headache, that's what we're trying to solve. And because we can schedule that before, and because we're telling you the day before you leave, nothing is really left to chance. It's deterministic. You just need to leave at this time, and everything will be okay. Trust us. That's really what we're trying to do.
We also need a point.
Hey, we'll schedule that beforehand too. There's a great app I just stumbled upon, but you can reserve a spot.
Spot Hero?
What?
Spot Hero?
Maybe that's it. Yeah, you just reserve a spot in the parking lot, and so everything's taken care of. We can do that too. So just quickly in the value props. Performance 10x better with kernel-less, so no handcrafting kernels if you need to do that. Lower power consumption, lower latency. But the biggest one, in my opinion, is more in terms of the product availability and domestic supply chain. Our lead times are 12 weeks compared to potentially 52. If you need a GPU, or you have to go wrestle with a hyperscaler to negotiate time to use one. And everything is designed, engineered, manufactured within North America as well. So a lot of the supply chain constraints you see with others, we don't really suffer from those. We saw the go-to-market strategy. Of course. The go-to-market strategy, you can play around with the API, you can go to the website, fool around with the chat interface, or if you want to get an API key and start building things, you can create a free one today. You can start consuming tokens. There is a rate limit, but it's all free. You can build apps, you can build demos, prototypes. And then the second is rack scale compute clusters as well. And these are the workloads that can be run on here are a little more bespoke and customized because you're literally working with you on premise as well.
So questions. So for these two cases, do you have like known customer you can actually share?
Yeah, so one of our larger customers is Argonne National Lab. And they have a cluster and they're running bespoke research and then also some large language models as well.
So that's for the home to.
Yeah, the bottom one, exactly. And other research institutions within the United States can access that, but then we're also part of the NAIR pilot program. And so researchers can request access at Argonne, or we're giving away 10 API licenses, or keys, really, for researchers.
If someone were to get like prompt two like a cluster or a certain amount of them, is it like trivial to, if you have your own model, to get it to run on them, or is it a more involved process?
I mean, it's fairly minimal configuration.
So how long did Argonne Lab took from getting the hardware to running the model?
Ooh, I don't know if I would be able to give you a good answer just because I joined
months or
after
weeks?
that. Oh, no, weeks. Not maybe 3 weeks. In terms of the install and then compiling and porting the model over to.
Does it involve even customizing the compiler?
No. Yeah. So at that point, it's really more of we're not a professional services company, and so we need partners to do that for us, and so it's literally finding people to do that for us. Yep.
Do you sell very small clusters? Or my startup is great. We have some of our own models that are small. We play with you guys. We're very excited. We just wish we could use it sooner. And that's part of why
We can sell racks. If you want something smaller, we work with a partner called, what's the name of it? We work with a partner to sell those, and if you want to talk afterwards, we can exchange information. I can get you that. Yeah.
Are there plans for like any sort of multi-agent integration into the website, like similarly to like Swarm or AutoGen, but like having a website version?
So we do have integrations with LangChain and Llama Index today that you can play around with, and a lot of the great community interaction that we're seeing on Discord, as well as people building those integrations for us too. So I think some folks have even built our integration too. Yeah.
I have one more question.
Yeah.
If we get the API key today, will we have it free for life, or?
No, unfortunately,
Okay.
in the summertime, late summer, that's when we're going to be turning on the metering. So.
Okay.
Yeah.
So who do you consider as a competitor? There are other players.
NVIDIA.
Well, NVIDIA is not really. This is a very customized sort of.
Yeah, it's hardware though. It's hardware for machine learning.
How about Sempanova?
No. Just NVIDIA. Just
NVIDIA. What about Google's TPUs, or are they just going to be in Google's hardware?
I mean, the leader in chips for AI is NVIDIA, and that's our competitor. And they focus on training and inference. We focus only on inference, but I think their most recent earnings report, I believe 60% of their revenue was from inference. And so that's going to continue to grow, and that's what they said.
I guess, could you see a Prong 3 go to hyperscalers and allow Groq to be accessed there?
Oh man, I mean, that would be lovely. Yeah, in my opinion, that would be lovely. But those conversations happen way above. Sure.
So I'm really curious just about just like further optimizations with if you could incorporate training, because I'm thinking that like if you could totally own like the model creation architecture and you're not suffering backwards compatibility to like NVIDIA and CUDA, then that could lead to like further gains. So is that like on the pipeline?
I mean, I think, well, what to our benefit, we're really focused on solving one admittedly big problem, and that's inference. There's a lot of subtasks with that: latency, throughput, types of models, multimodal, things like that. So yeah, probably it would be great to incorporate that, but I think we want to make sure that we're checking off those boxes first, and then move on as well. So I think some folks over. Yep.
A follow-up to this question for edge-based applications. How long do I have to wait until I can get my hands on it for edge-based applications?
What type of edge are you talking about?
So let's say like, I work with NVIDIA Oryx for unmanned ground vehicles. So, how long do I have to wait? until I get my hands
So we could potentially support a heavy edge, meaning like a rack. But I mean, you'd be surprised. Some customers, that's what they define as edge, right? It could sit in a giant vehicle. So yeah, we could support heavy edge. Something more, a smaller form factor, it would probably be a couple of years out as well. You in the back with stripes.
So, two questions that are kind of related to the industry as a whole. I see that Intel, Qualcomm, and Google, I think Samsung as well, are working on a CUDA competitor called OneAPI. I imagine AMD is going to go in with them at some point, just so that there is a complete competitor to that. Is there, I know that that's more on the training side, but is there any research that y'all are doing into joining into that crowd?
Not to my knowledge. There could be, but and we stay in active communication with all of those organizations too. But to my knowledge, no.
And then the second question is, I know that in your the diagram of the processor as well, the big benefit that you pointed at was that you're not using HBM memory, you have a flat memory that the entire processor has access to, and that is one of the huge benefits of it. It's just that it doesn't have to chunk up memory as much. Isn't there some threat then by Apple in their M1 chips, or the Apple Silicon chips, which have similar architecture? And now I see that Qualcomm and Samsung are making similar ARM-based chips that have memory on the die that they all have access to. Especially if this like one API thing takes off, isn't there a threat from there, even though that your processors will have a huge latency benefit over them and the security benefit I mentioned before of not having branch prediction?
I mean, I think we're not impervious to threat at any time. I mean, there are a lot of great organizations and enterprises doing amazing work. But having said that, I think based on our calculus, if someone were to try to start today, they would be 2 years out from where we are today in terms of not just thinking from a holistic approach, software, hardware, the integration points. We get asked a lot, okay, so if someone were to potentially steal this IP, could they, do this? And the short answer is no. The tricky part is connecting all of them together. Not to say that the software and hardware isn't tricky, but putting them together, that's really where you see the novelty.
So it's the hardware plus your really good compiler that gets all the scheduling to you so fast.
Exactly, and then just how we interconnect the system together as well. In back.
So you go to like sell these hardware to like cloud providers like AWS or Azure eventually?
I think that's probably one goal. Yeah. Yeah, I mean, we're trying to build out a Groq cloud too, and so we want Groq to be the number one shop for inference-based AI workloads. And so to do that, we can slice out a number of different ways. Right now, we're focused on building our Groq cloud to accomplish that.
So a non-technical question. So it says on the slide that you are selling tokens as a service. So does it mean like your business model is more of a subscription-based plan where you rent out your hardware to people who need it and then just charge them by month?
I mean, so token as a service is more like when you think of OpenAI and ChatGPT. There's a Python API they can use, and you pay based on the amount of tokens that are processed, the amount of words that part of your initial question, and then the words that are generated too. So for developers who are non-enterprise customers, it'll really just be a pay-as-you-go model, like any hyperscaler. You spin up an EC2, you use it, you spin it down. That's all you get charged for.
So would it be possible for a customer to just make a one-time payment and buy a whole set of hardware once and done?
Buy hardware? Oh yeah, that's the second prong at the bottom here. Yeah. Having said that, for enterprise customers too, we are working on partner programs. So you agree to spend X amount, and these are some SLAs and tokens you will get. Yep.
So for now, you are focused on large language models. Any plans for like diffusion models, anything like that? Multimodality?
Yeah. So it's definitely on our pipeline. We on the website you saw we have a number of different large language models. We're releasing Whisper in the next couple of weeks. We will also begin releasing multimodal models as well. The team is actively looking into things like Llama.
How many racks do you need to buy to run Llama 3 model?
Llama 3. Which?
70.
Oh,
doesn't matter.
70.
I mean, do I need to buy like one? Do I need to buy like 10 or scale or like?
Yeah, I mean,
does it is there any difference?
So I mean, that's not a necessarily easy question to answer, because you need to think about how many users your system will support too, and the number of the ratio of input token size and output token size too. So without knowing anything about your workload, the amount of customers you need to support, input output ratio, I can't say 10 racks, I can't say 5 racks. It's really and that's kind of the hard conversations that we've had to have with customers, because with an API model, it's literally, okay, here, like, you built out the hardware so you can satisfy that demand. For on-prem, it's really working with folks to understand the business and use case around that too. So I know that's not a great answer, but that's what we're able to. Yep.
What would have to change about your stack in order to support other different models, like images or diffusion or something?
I mean, we support them today.
Okay.
But over the last 18 months, the strategic direction of the company has been more focused on large language models.
Okay.
So dramatically reducing the AI, the inference speed for things like Llama.
So 2 last hands, I think, and then
last question.
then people can chat afterwards.
At the end of the day, if you're creating a compute cluster, you're still going to be limited by the networking between those clusters, the total rack switches or optical switches that you're using. What is that latency, and what thresholds make it not stop that scale?
I mean, we honestly haven't seen that yet. We've been able to compile models at like 400 billion parameters or more, and we haven't really seen any of those performance degradations.
So right now, if you look, sorry to interrupt you, but if you look at the NVIDIA side of things, right, that probably the most complex cluster is the Israel 1 model, Israel 1 cluster. Could you grow that big?
Yeah, we haven't seen any evidence to support that we couldn't.
I saw one last question, I think, over there. Someone had a hand up. Yeah.
I'm a student, so this is going to be a really generalized, zoomed-out question, maybe to round everything out. But in a world where large language models replace operating systems such as Linux and the FAR feature, there's investment potential for your company. Like, where do you see your place in that world?
Come on, Jeff, pick an easier.
This has like been an amazing test. I've never seen so many questions. 1 and 2, just like every angle coming at you here. So.
I mean, I don't know. I don't have a company specific answer to you.
for you, like, first.
Or us. We test.
I mean, if I can.
For
if-
everyone who gets replaced by
If, how many of you have seen the demos that ChatGPT 4.0 released yesterday?
Not yet.
Oh wow, only a handful. Okay, so they're really, really, really amazing. Just being able to switch seamlessly between multimodal, text-based, audio-based, and even more dramatic than that, being able to install a plugin on your computer where it can literally see your Python notebook and optimize the code or tell you what's happening behind the scenes. So if anything, if it's going to get better, which I think it will, I think it's going to be more of a companion. At least that's what I would hope. More of a companion that can help me and others to optimize their life.
Awesome.
Yeah.
Thank you, Alex. Super cool. I'm sure people want to chat with you. Alec, you're going to head across the street after this, or are you?
For a little bit.
Okay, so across the street is the place to catch Alec. I'm going to say that now so everyone's just trying to catch you right now. You don't get to leave the room. So follow him. Still good. Still good. See if people follow that.
Yeah,